Good afternoon. We can see we've got some people joining the webinar already. Since we're starting a little bit late, sorry about that. Let's just crack on with it. So today, my colleague Julian and I, we will introduce ourselves in a minute. We are going to be presenting on back to the basics in pvDesign. So essentially addressing your most frequently asked questions. Okay, so brief introduction on our end. So first about myself. My name is Gonzalo De Blas. I work as an account executive for the UK and Ireland here at RatedPower. And just to give some background, in the past 3 years, I have worked with around 30 clients to ensure their design and engineering processes are the most time and cost effective in order to maximize their profitability and competitive edge in a rapidly changing market. Julian, if you'd like to introduce yourself.
Yeah, of course. Yeah, thanks, Gonzalo. So yeah, I'm the technical advisor at RatedPower. I'm covering Germany, the German-speaking region, and the Nordics and UK. And I'm basically there to support the clients in any questions. So I dealt with many of the FAQs here. So yeah, let's just get started, I guess.
Brilliant. So a little summary first on the things we will be covering today. Oh, sorry about that. On the things we will be covering today. So first, we'll talk a little bit about some background about who we are at RatedPower, and then we'll move on to tackling the different frequently asked questions that we get from you guys. This is both from non-users, so non-user level. First, we will tackle this first as it's more general, probably more relevant for everyone. And finally, we'll get to more nitty-gritty of actual user level frequently asked questions. On this, we wanted to get an idea of, out of everyone that's attending today, how many of you have used pvDesign and how many of you are not users. We're gonna activate a poll, so you should be seeing something on your screen. So if we could get some answers on that, that'd be super helpful for us. Okay. I'll give it a few more seconds before sharing my screen again. Okay, I can see we've got a bit of both, users and not users.
Yeah, I think we might have expected that, right, Gonzalo?
Yeah, correct. Okay, so apparently this, you should be able to see my screen again now.
Yes, we do.
Correct. So great. So first, like I said, also at the end, we're going to do a Q&A session. So a few minutes at the end, we're going to be talking about, it's about frequently asked questions. So not just the ones we have come up with that we hear the most from you guys, but also we want to give you, the people in this webinar today, a chance to ask any questions that you might have live. Okay. Before that, though, I would like to give some background into who we are at RatedPower. So just in a nutshell, we're a software company. We provide value for developers, EPC companies, engineering firms, as well as banks and funds. Okay, we work with these different players in the solar industry, each of which find value in our offerings from their own perspective. Okay, our main use case being prospecting, finding, and maximizing new opportunities faster than ever. Okay. We are on a mission to accelerate the energy transition by increasing global solar energy capacity through disrupting and user-friendly cloud-based solutions. Okay, and here we have just some examples of companies that we work with. Okay, briefly mention some of our customers. Here we've got some big international names like Shell, Iberdrola from Spain, Cubico from the UK, BayWa from Germany, just for you to get an idea of the sort of companies or names that we work with internationally. And finally, to summarize some of our milestones and track records, I think this sharing, there you go, sorry. We work with over 300 customers. with roughly of just over 2,600 users, and they have used our software to simulate over 9 terawatts worth of solar PV. Okay, so now that you have this little background on us, we get this done with, and we can move on to the non-user level frequently asked questions. So for this, I'll pass it over to you, Julian, first.
Yeah, no, perfect. Yeah, I will just start with the first frequently asked question, which we get a lot in the beginning, of course, for non-users as well. So what's the difference between us and other tools? And I just try to list a few points here. So I start off with it being cloud-based. So what we believe and what we can actually show is that our simulations are super fast. If you want to do optimization, that speed really helps in such cases. As a second point, I wanted to show that we don't only cover one part, like the layout, we cover more. So we have layout, energy yield, the documentation as well. So there is a broad offering in what the tool does. And then, because this is sometimes very specifically for the ground-mounted tools, that it also covers the medium voltage side as well. So we don't only cover, DC voltage and the PV plant itself. We also talk about substation, layout, about the cabling. So all of that is included as well. So that's why I just mentioned that in point 3 there. Well, yeah, point 4, it's about user friendliness. So in this screenshot, you can see it maybe a little bit, but the interface is, we try to keep it very clear, very clean. So it's easy to access, easy to use, which we believe is a great benefit for a broad range of users. And then the last part, I just kind of picked from those cases when users, they come from the from other tools where they might be limited in certain, like in modules for ground-mounted designs. So we don't have any limits on modules in that case. There is a maximum limit in terms of hectares, in terms of area, but that is quite large. So we have plants simulated up to 2 gigawatts. So we really believe there is not an upper limit really. So yeah, let's just go with the next question, I guess.
Brilliant. Thank you, Julian. Thanks for that. Very informative. Great. So the next question we hear a lot is, do I need to download pvDesign on my computer? So I'll take this one. pvDesign is a cloud-based software. Okay, it lives in the cloud, meaning you don't need to download any software or any files. You access this directly on your browser. Okay, on your favorite browser. Normally, we recommend Google Chrome or any other browser that you prefer to use. Okay, this has certain benefits. Okay, namely, the first one I wanted to mention is there are no particular power requirements. Okay, so it doesn't matter which computer you're using, or even if you're using a portable device, because you need to access a project last minute to download some of the documents you've generated with it. That's something that you can do. Okay. This also means all the calculations happen in our servers. Okay, so this is something Julian has touched on, and we will be covering some of this later on as well, but the speed at which you can create designs on pvDesign is extremely fast, since the calculations are done on the server instead of locally. Another thing this means is you get very frequent updates. Okay, again, we will talk about this later, but as it's a living software that's on the cloud, we launch updates all the time to fix things, but also to add features based on your feedback. Okay. Since we're talking about downloading, I wanted to mention here, as it's more or less related, the documentation that you can download from pvDesign. Okay, so with pvDesign, for every project that you make, you will be able to generate certain reports that come in Word format or PDF, such as energy yield reports, design reports, as well as some for the interconnection, as well as the BESS. You get different spreadsheets that you can download in Excel format, like a bill of quantities or bill of materials, listings of cables and costs, financial analysis, and finally some AutoCAD ready drawings, such as a layout. You get a 3D layout. You get a 3D shapefile, 3D shading scene in PV Colada format, as well as some single line diagrams. Okay, this all comes in different languages as well. We currently work with 6 different languages, so this is also something we get asked a lot. So just to mention, we work in 4 different European languages plus Japanese and Chinese. So it's something worth mentioning as well. Okay, on to the next question, which is for you, Julian.
Perfect. Yeah, I mean, you touched upon it already about the updates, and I just wanted to get that question out here because it's asked a lot in the beginning. So what happens in terms of updates? We launch updates every now and then, literally. So they're ongoing. Whenever there's a new feature, it's implemented right away. We then, and this is the screenshot, what I wanted to show here is we update, or we share those updates in a summary per month on our website called the knowledge base. And we also, every quarter, we have a webinar talking about the recent updates as well. So we kind of keep everyone on track what happened, because some of the updates you might get notifications on it, some others might happen in the background and just help to just speed up the things and the processes. I guess it might be a good point to maybe open the knowledge base here. If Gonzalo, you can do that as you're sharing the screen.
Sure. Let me just handle that.
Because yeah, I mean, the knowledge base is basically our website to go to, where you can find answers to most questions. And there is also one spot where we have and share all the latest updates. So yeah, I guess that would be something we can maybe show now, to just show the latest updates.
Great. So here we see our knowledge base. Okay, we're going to be changing from the PowerPoint to also pvDesign later. But this is the knowledge base that Julian was mentioning.
Perfect, yeah. And we can see that the November updates are there. So yeah, maybe you can just click on one of those as an example. Perfect. So we can see backend, front end, and then see the new features. Exactly. Yeah, and this website is yeah, everyone can open that. It's publicly available. So that's why we just want to highlight that. And I guess that's it for the non-user FAQ. So what do you think? Should we jump into the user ones?
Definitely. Let me move back to the presentation and let's go to the user level. Okay, so user level. So the first question here will be how extensive is your equipment library? So this is a question we get asked a lot. So how often do we update this? How does it work? Do users have to manually import the equipment they want to use? So I want to explain a little bit on this. Our customer success team conducts regular campaigns where they're in touch with different manufacturers. There's not a set frequency for this, but just for the purpose of this webinar, I checked yesterday, and this was last updated on November 28th, okay? So it is quite frequent. And just for you to get an idea of how large the public database is currently, we're looking at over 5,000 modules, over 1,200 inverters, and over 500 structures, okay? However, we understand sometimes this database might not contain exactly what you need it to contain. So we do also give users the option of using a private database, okay? I'm going to share pvDesign with you now, so I can show you what this would look like. We have prepared a project for this webinar. So when we select the equipment that we want for a particular design we're working on, here at the equipment selection tab, we've got PV modules, inverters, and structures where you can select. So this is what our public database would look like. Okay, you have the option of filtering, searching. We work with both monofacial, bifacial modules, centron string inverters. The database would look the same. And finally, for structures, we have single axis trackers as well as fixed structures, which you can use in an east-west configuration. And the last option I was talking about just now would be here. We would be able to upload any pan formats, modules, OND format inverters. So in the case that we want to keep a private database or have the latest in the market, or even an exclusive agreement with a manufacturer whereby we're using something that's not in the database, we can use this. In the case of structures, as there is no standard specifications sheet or file, you can also manually, so it's takes more manual work, but it's also much more tailored. You can manually create your own trackers as well as fixed structures based on the configuration that you need. Okay, so I believe I have covered this question, and now we would be moving on to the next question, Julian.
Perfect. Yeah, that's me. So it's about the one question, because we wanted to mix it a little bit about frequently asked questions and also the questions we receive from attendees. So it might be a question from one of you. And this was related to the grid inverters. So what kind of information we give, what efficiency ranges. And I just tried to show you here two, let's say, screenshots from the infos we take from those OND files. So from that files we upload for the inverters. On the left, you can see the kVA curves. So about, well, how the temperature dependency is on the maximum power output. And then on the right, you can see the efficiency curves depending on the voltage load. So basically these values we will take for each individual inverter. They are uploaded and they're, in the OND file. So these are the values we take. And then we kind of get that energy yield based on these curves. And this is the information we have amongst others. There's others as well about the MPPT tracking, about the operation window. I believe we can show that later in pvDesign. Maybe not now. We can continue with the next question and then just cover it in the next time we share the software. Last time with you, Gonzalo.
Brilliant. Sure. Great. So the next question for this one, it might be worth sharing pvDesign. That way we can go back. This is related to also what I was mentioning earlier regarding the documents that you can generate and download for every single iteration or design that you make on pvDesign software. So one of these documents will be a PVsyst compatible shading scene. Okay. That said, pvDesign does have its own independent energy yield model. We have developed it well since the company started in 2017, and it's been verified externally as well by Black & Veatch. They wrote a report comparing 3 different case scenarios using pvDesign and PVsyst, and the biggest difference they found was ±1%. This has also been used by our clients in quite a few years. So we are very confident in our results. However, we also want to give you the option of exactly exporting your data to PVsyst. This is why we implemented this pvcolada.pvc file that you can download. I'll show you what this looks like on pvDesign, and that way we can also have a look at all the documents that are generated, as well as the inverter configuration that Julian was mentioning just now. Okay, so here we are back to pvDesign and to the design that we created for this webinar. And in the case of this iteration, if I wanted to download the documentation, I would click here on documentation, and anytime now we will have the list of the documents that we can download. Okay. It seems my internet connection today is not the best. There you go. So the documents that I mentioned earlier, different reports, spreadsheets, and drawings, you have an idea on this. It's quite lengthy. It's over 300 pages. So probably we definitely won't be able to cover everything. So if you want to know a bit more about any of them, feel free to reach out to us after the webinar. And as I was mentioning, we have here the 3D scene in PV Colada format. That's PVsyst ready. Perhaps, Julian, it would make sense to go to the inverter section now.
Great, yeah. So yeah, you can open any of the details of any of the inverters, and basically you will see the screenshots I took earlier exactly. And on the left, there's a few more infos which we draw from the OND files. So I mentioned the MPPT surge range, maximum input voltage. These things, they can really help in simulating the inverter, as close to reality as possible. Great, yeah, thanks for sharing. That's great to see.
Great. So the next question, this one is for you, Julian.
Yeah, perfect. Yeah, I mean that's of course, if you get started as a user, you are asking about what are required inputs, and I put them first. So basically, what do you need to kind of start a design, and we call it the site. So you have to define an available area. I mentioned the 4 elements which are necessary. So you have an available area. You have to define an access point as well. So basically, where you will have the gate, where the roads come together. A substation area as well, and this is referring to the medium voltage side I was talking about earlier, and corresponding with that area is a medium voltage connection point. So these 4 elements you have to define. Of course, you can upload them if you have those areas defined in a kind of boundaries in an AutoCAD file. You might just have to convert your DXF or your shapefile into a KML file for now. So this is the kind of format we accept. And then you just upload the KML file and you're ready to go. And if not, you can just create those areas in our software itself. And then if these inputs are given, and we can maybe show that as well later, but then the automatic inputs are the topography and meteor data, so that's given by us. Of course, you can change it anytime you want, but you would need to, you would have to kind of upload your own manual data there. But for topography, we give you the Google Earth data, and for meteor, we will have PVGIS and NASA as the default automatic inputs. And then I just listed a few most common inputs here, which are basically the first things a user would change. And of course, that's the equipment. It will be the module, the inverter, and the structure. And then the DC to AC ratio, so how you want to kind of attach your strings to the inverters, on which ratio. And then lastly, quite important as well, and we might cover part of it later as well, is the pitch distance. So depending on what pitch distance you want and want to simulate, you can input that as well.
Great. Let me go back to the design. Perhaps we can explain, maybe some of these things are a bit unclear. If we explain it in a more visual way, especially the site creation, I think it might be super interesting for our attendees. So if you wanna show us, Julian, when you create a new site altogether here on pvDesign, remind me what the basic inputs would be here.
Yeah, perfect. And I think what is great that the software will give you that indication on the right as well. So you can see those 4 elements here. It's the available area. As I mentioned, it's kind of a polygon you have to draw. It's then the access point, which is that axis where you have the gate where all the roads come together, and then substation area as well. It can be somewhere else where your point of interconnection is located. It doesn't have to be close to your site, but it's basically also an area you define. And then the medium voltage point, as mentioned before. And then, I mean, of course, there's other elements as well you can introduce here, but they are just the most, the necessary ones. So that's why it's good to show them here. And then maybe, we can cover the automatic parameters here as well. It's the topography and the meteor data. So you can see already there is Google Earth and PVGIS listed. So the user doesn't have to do anything. But you can also see that upload button where you can choose on uploading your own as well. So we really want the user to feel that he can do all the changes he wants, but he doesn't have to do them. So you don't necessarily have to get those meteor data, for example. You have a starting database. I remember that the next question was about uploading topography. It was also a question given to us by one of the attendees. So yeah, perfect. That's great. So they were asking about a different source, like LiDAR data, for example. And what I put here is basically that our software is a global one, and we try to find data sources which are globally available, which is, for example, Google Earth. And for LiDAR, we haven't found any global available source yet. So that's why we would provide you with the Google Earth data. But, and this is going hand in hand with what I mentioned earlier, you can of course upload your LiDAR data as well. So there is no issue with that. And for that specific example from the attendee, it was about a US LiDAR data. And yeah, if you have the website, you can download those. You can just convert them to CSV here and then use that upload function, which is pretty straightforward and of course also emphasized by us. We want you to have your data uploaded if you want. Great.
Brilliant. Thank you, Julian. So next question is, do I need external data sources to work with pvDesign? Again, this is all connected. So going back to the data we have by default, meteorological data, but also topographical data. This applies also to horizon and albedo data. Okay, so they all come with some set data source that can be customized. Okay, so we saw how to do that with topography by uploading a CSV or cloud point format file. Meteorological data, we have API integration with SolarGIS, SoCast, Solar Anywhere, and of course, like Julian just mentioned, the user can also upload their own. So if it was a different format, I don't know, a Meteornorm or even their own generic data they have generated, produced, whether it's hourly or sub-hourly, they can use that. Okay. And likewise for albedo, there are some satellite data they can use. However, they can also define their albedo profile, whether that's yearly or monthly. And for horizon, either using the default PVsyst 5 data or uploading their own horizon profile. Okay. So moving on to the next question.
Perfect. Yeah, that's again from my side. So it's about the pitch distance. I briefly mentioned it, and on the right you can see actually the pitch distance input. And the question we receive a lot is, where does that recommended pitch come from? Because you can see here on the right side there is a recommendation given from pvDesign, from our software. And basically, the recommendation is given based on inputs like table width, tilt angle, sun elevation angle. So we take all these values, and then we want to ensure that there is no shadow on your modules for 4 hours during the winter solstice. And in some regions, and this example here is taken from Spain, this will end up in a recommended pitch for 11.3 meters. And just noticing here, so the pitch includes the table as well. So it's table plus the clearance distance in between, just for you to understand. And this is where the recommendation comes from. And then of course the user now can change that, and when you show pvDesign, we might have the chance to also show the batch mode, because sometimes users continue asking after that, okay, hey, this is a nice value, but I want to optimize my plant, and I'm not sure what is the optimal pitch. So we introduced a tool called batch design, and this allows the user to kind of simulate 10 different pitches with one click. And by doing that, they can very fastly find out what might be the more optimal pitch. And yeah, this is exactly what Gonzalo is showing right now. So what you can see is, you can see 10 different design iterations. The pitch distance is changing. It's the first column here. And if you would click on generate designs, the software would run those 10 designs automatically. It might not take a long time, and then you can easily compare those and identify what might be the best pitch in terms of energy yield or in terms of LCOE. And I believe that's is answering that question, where that comes from. Maybe you can quickly show where you can see that pitch and the recommended pitch in the design process. So if you would click on layout, in distances, this is where the users would find the pitch. Exactly, yeah. Great, thanks. Yeah,
Perfect.
we can see on the right that is running the simulations when they're done.
Great. Okay, some of these are already ready, so let me save them and we can show you what the comparison that Julian mentioned would look like. Okay, at least these few ones. So now that they're saved, I would go back to the main view where I will have the different iterations that I can now compare. Right, Julian?
Yeah, correct. Yeah, exactly. So that's kind of the tool which goes hand in hand. You have the batch mode, and then you have the comparison tool, where you can, yeah, very easily see, and even it's highlighted what's the best value in terms of LCOE or specific production. So, and then if you want to continue working with those values, and this might be also quite helpful for users, is the export function here on the top right, where you could kind of export those values and then continue working in analyzing them further.
Great.
Yeah, there's a graphic output as well.
Great. So The next question we hear a lot is about how when generating a layout, as it's done mostly automatically, how does pvDesign decide on the road placement? Okay, so for this, the user has a few options to select from. So they might want the roads to be laid out vertically, horizontally, along the perimeter. And in the case of smaller polygons, they also have the option of minimal roads, as well as no roads at all in the case of even smaller polygons. Okay. As this is done mostly automatically, it will be done by taking the power station location, which will be as central as possible within the block, okay, which the software will try to make as square as possible, and always accessible through a road, okay? So again, the roads run through the middle of the blocks when possible. I know it's maybe a bit difficult to visualize this, so let me just show you what this would actually look like with an actual regular design, which I believe is this one. Okay, so we can see here, this is the finished design, and we can see the blocks, they're more or less square, and we can see the power stations, how they're located on these roads. Okay.
Exactly, yeah. That's great. That's great to show that, because I feel like sometimes users might ask, okay, where is this road to road distance coming from? And I feel like in those blocks you can see it. And by the way, those blocks, of course, doesn't mean that this is a finished design. It's just for visual purposes. And you can choose an adaptive design later on to really adapt to the boundary.
Correct, or even have smaller tables at the edges and things like this. Great. So we wanted to leave some time for, of course, questions. This is all about your questions. We already have a few in the question box in the chat. It would be great if we could get some more. Take an opportunity today to be able, to ask these questions to us directly. And while you type some questions, I'm gonna start answering some of the ones we already have. Okay. So the first question from the audience says, does pvDesign support rooftop projects?
I could take this one if you like.
Sure.
Perfect. Yeah. So I mean, we started by sharing the software already, and you probably have seen a lot of ground-mounted plants, and this is actually our focus of the software. So we don't support rooftop like applications or PV plants on a rooftop. So we are literally focusing on that greenfield, on that ground-mounted utility scale, and try to optimize our tool towards that. So yeah, unfortunately for a rooftop, you would have to work with another tool, but whenever you have ground-mounted projects, that's the way to go.
Great. Thank you, Julian. The next question is, in what languages is the documentation available? So I touched a little bit upon this earlier. I did not mention the specific languages. So of course, English, we have Spanish, Italian, French, and German. So that's 5. I said 4 earlier, so that's 5 European languages, plus we also have Chinese and Japanese. So in total, we have 7 languages, both for the interface. So if any users within your company are in those locations or want to work in those languages, they have the option of doing that. And if your projects are located in countries where they speak those languages, you can download the documentation in those languages and use it for grid applications or requests for proposals or any other purpose, engaging with different stakeholders directly in the local language. Okay. We have another question that says, where can I limit how much energy my plant is providing to the grid?
Okay,
Julian, do you want to take this one?
That's a nice one. Yeah, maybe that would be helpful to share the software
Sure.
in this case, because it's simply a parameter you can just enable.
So I'll clone here.
So this question might have come from a user, I suppose. So if you would go to the layout, and then for power requirements, exactly. So you can curtail, we call it, so energy clipping. So in this case, even if you have a plant, and in this case, we can see we have around 35 megawatt DC installed on these 3 polygons for that example. And if your grid can only take a certain amount, then this is where you can kind of limit that and do that energy clipping. We will list later on in our documents how much energy in each hour would be kind of lost to that clipping, so you can analyze that as well. But yeah, so short answer, this will be the parameter you can use. We call it the active power limit. But just just for the users to make sure to not enable it and call it 0 megawatts. So if you enable that part, you should also type in the kind of limitation here. Exactly, right.
Perfect. Okay, we have another question. Are we able to modify and design manually in terms of roads, power stations, etc.?
I can also take this one for example. So in terms of manually, I believe so there's two answers to that. So the first thing, of course, you can change all these parameters manually, and even now sharing the software, we could maybe dive quickly into the layout configuration here to just show the road layouts, for example. So if you go a little bit lower to the layout, this is where the user can manually select this road layout. But I believe this question was also directed towards manually defining each road, power stations as well. So in this case, there is an option to draw any path, any shortcut you have in your site. So you can do that when defining your site. But the really manual drawing of roads and placement of power stations, that could only be done in our final outputs, the AutoCAD files, for example. So you can just download the AutoCAD file, the AutoCAD drawing, and do these final changes there. But in terms of software design, we try to give as many different parameters you can choose from to optimize it, but you cannot really manually define the road, for example. So here in this example, I can see that the roads, they look evenly distributed, and this is the automation we have in our tool. A little add-on to this, for example, in this specific case, because users asked it a lot as well. So can I do manual changes? What we try to improve in this case is allowing the user to have different inputs for each of these polygons. So we saw 3 polygons, and yeah, maybe Gonzalo, you can enable that option. It's the layout option here. So by allowing this, the users can modify the road layout. They can modify, in a way, the power station placement as well. So this is what we try to solve for the users, to have more flexibility. So in case you have any specification, you might want to isolate that polygon and do that specification by defining it as its own polygon. And this way you can even do further changes. And yeah, for example, here Gonzalo shows the power station location, so we can either place it outside or inside the DC field. And this essentially means if you leave a gap between the road and the DC arrays, or if you locate the power station, let's say inside the DC array. I hope this answers the question. Maybe Gonzalo, if you have anything in mind which can help in that question as well.
Mm-hmm. No, I think you answered everything. There is no way of directly moving things around, but there are ways of making the software do what you want it to do. So we saw the inputs here. Also, by playing with in the site creation, Julian mentioned how you can place certain paths that were already there. Also some exclusion zones. So by playing with those, you can make the software do something like you wanted to do, but you will not be able to manually move things around unless you do it in the output, so in the AutoCAD file. Okay. We get a different question. Can we have different pitch distances in the same PV plant?
Yeah, and this is actually perfect. A good question for what we just discussed. So yeah, this is what we tried to improve in the past. So here, for example, if you would want a different pitch in polygon 3, and this is just for this specific example, you could now click on distances and then select the polygon number 3 and apply a different pitch here. So yeah, if you would do that and run design again, we will have a different pitch in polygon 3. And we could see how this is kind of influencing our energy yield. And of course, it doesn't have to be in such a large polygon. If you have a certain area you want to just modify slightly, you can cut that polygon, for example. You can make 2 out of 1 polygon, so you can really play around here. So yeah.
Great. Thank you for that answer, Julian. We had scheduled until 45 past, so in order to finish in time, we won't be able to take any more questions. But if you do have any more questions, we highly encourage you to get in touch with us, and we will connect you to the relevant people at RatedPower that will be able to help. And just wanted to thank everyone so much for attending today. The recording of this will be made available for everyone as well. And again, thank you a lot.
Yeah, thank you so much.